All right, welcome back to Universe Sandbox 2, and I've been told so far that there has been an update. This is Alpha 17. What they have in Alpha 17 now is, I guess there are. Let's go to Earth right here. There is likelihood of life on planets. Let's see if I can. Where would that be? Likelihood of life. Display mode default. What's this? Elevation. I can have. Whoa! Okay, hold on. Slow down. Okay, I don't remember this being here. I can get my planet by elevation, and obviously that shows the continents. Those are higher up than the oceans. But where is the likelihood of life? So I could actually terraform a planet, and we're doing more terraform. Didn't I terraform? In the last episode, I terraformed Mars and Venus, but now it looks like I'm gonna have to terraform something else and try and get it to support life, which is really cool. And mass loss. Oh, comparisons. Okay, here we go. Earth similarity. Apparently, Earth itself is only 0.999, like Earth, and life likelihood is 0.994. So this isn't perfect. So can we get a planet that is 100% perfect? First of all, can I change this value? No, I can't. So I'm gonna have to work for this, and we're going to try and legitimately terraform a planet that can support life. This will be the confirmation. Oh wait, I can show that magnetosphere as well. Whoa! So this is the magnetic field, and that's, I guess, I'm assuming it's got this oval shape because over there is the sun, and then you pretty much have the sun rays affecting that magnetic field, being, I can't think of the word, bombarded. It's being bombarded by solar radiation, and it's making the magnetic field astute like that or something. I don't know. Oh, there we go. I've never had this work before, and you guys have told me, it's like, you know, you can show the habitable zones of solar systems, right? But whenever I would click this, it would never show up, but now I can finally see the habitable zone. So yeah, as you can see, Venus is just outside of our habitable zone. Earth is actually on the edge of the habitable zone, and Mars is just in the habitable zone on the far end, so it'll be a colder habitable planet. But what if, since this Earth is not perfect, but what if we create the absolute perfect habitable planet, and we'll put it right in the middle of our habitable zone? Pluto? Should we maybe that's what we'll do. We'll start with Pluto, and we're gonna make Pluto habitable in the habitable zone right in the middle. So temperature's at -68 Celsius. What can we do to Pluto here? We need to add a lot of atmosphere. Or actually, let's show the magnetosphere. Nothing! We need a magnetic field for Pluto right here. Magnetosphere, okay. Let's increase this. Magnetic field, here we go. Oh, perfect! Okay, now we have a magnetic field, and I don't know how much the Earth's is, but we're gonna keep it going up. We need to have life. What's the life likelihood? It's still 0. Keep increasing that magnetic field, because we can't have the sun giving all of our life cancer, because that's another thing about our magnetic field. If we did not have this, we would get super cancer from the sun. And that's one reason why we haven't gone to Mars yet, because that is a big deal, but they would get so much cancer. Or I'm just gonna start quoting The Martian. They'll get so much cancer that their cancer will get cancer. Was that in The Martian? I'm pretty sure it is. I learned a lot from that book, and I definitely recommend reading The Martian if you haven't, because that is a fun book. And watch the movie as well, although I like the book more. But this is about Pluto. Pluto is going to support life. Okay, so life likelihood is still 0. So now that we have our magnetic field, and I don't even know if this is comparable, I'm actually gonna go back to Earth and just compare. I'm just gonna cheat a little bit. Oh, actually, Pluto has a bigger magnetic field than Earth itself, so that's really interesting. Don't worry, we're just gonna keep it as is. Okay, so temperature is still at -68, but now we've gotten rid of our, we can really block the solar radiation. So now what we need is an atmosphere. Because one thing about, actually that's what NASA came out with about Mars, is Mars has lost most of its atmosphere from solar radiation. So with this magnetic field, Pluto will not lose any of its atmosphere from solar radiation, because the magnetic field is pretty much deflecting those rays. Can I add the atmosphere? I want to add an atmosphere to you, please. Atmospheric mass. Okay, it's got jack shit. Surface pressure, here we go. Surface pressure, I'm just gonna have it at 1 atmosphere. Or not that many atmospheres, no, we'll end up pretty much crushing the planet, probably. Okay, so we have 1 atmosphere for Pluto. How much atmosphere is being lost, though? I don't even know. Let's go to the likelihood of life. Temperature, materials. Likelihood of life is still 0. Although Earth similarity is 0.447. So that's looking good. So now what we need to do, we need to add some water because this there's no water left on the planet. Keep adding more until we start seeing some oceans. Why are we losing all of our water? We're losing all of our water for some reason. Look at that. I dragged that there and then it's slowly disappearing. Oh! Why? Why? What's going on? Our water is all boiling away for some reason. That I don't know. Surface temperature is at -49 Celsius. How is our atmosphere? Atmospheric mass is still at 1.07 atmospheres. Greenhouse effect is at 303. Wait a minute, 303 Celsius. Why is the greenhouse effect so high? Oh, will that? Ooh, maybe that's why. I think the effective temperature is at -68 Celsius. But this thing is warming up at a rapid rate. I'm going to turn down our magnetic field here because I guess maybe that I don't really know too much about magnetic fields, but I'm gonna guess. Okay, so let's keep it to about this, and maybe things will be a little bit better. The temperature is at, all right, yeah, the temperature is not rising as much, but it is still heating up. Let's try adding water again, and maybe that's not gonna start basically boiling all our water. The water is still boiling away. That's ridiculous. Come on. But it's adding to the atmosphere, though, which is really weird. I don't know my physics here. What is causing this? They've added so much stuff. I don't know what the radiative power... what is doing this? Why are you boiling? Is it the silicate? Maybe we need more iron in here. Give us more of an iron core. Okay, less silicate, more iron. Give me some water. Nope, still not working out here. Mars? Wow. Does that really happen with Mars? Mars loses 33 kilograms per second from just solar radiation. But if we go to Earth, Earth loses not a lot of mass at all. So solar radiation is brutal. So how much of a magnetic field are we gonna have to create for Pluto to not lose all of this mass? We're probably gonna have to create an insane magnetic field that goes so far in order to maintain Pluto's mass. Nothing is going to come within Pluto's distance at all. This thing has to be protecting me from solar radiation. What is causing this mass loss? So, I don't know how much this plays into things, but I guess the mass of the planet matters when it comes to the magnetic field and mass loss. If the planet is too massive, it's going to be more likely to absorb radiation. I don't know. Basically what I'm saying is I had to make Pluto the same mass as the Earth, so I guess Pluto is just way too massive. The gravity, the temperature, basic. Surface gravity is 5.97 meters per second squared, even though the mass of it is 1 Earth, because surface gravity, oh wait, escape velocity is 9.88 kilometers per second. But why is the surface gravity 5.97 meters per second squared when it's the mass of the Earth? You would think that the surface gravity would be, unless it's denser? I don't really know. Okay, whatever. We basically have about a little bit less than half of Earth's gravity, which is strange, but we have gotten rid of the mass loss, and we just need to shrink the water a little bit. We need to change the temperature here. Surface temperature, I'm gonna put it at -57 degrees Celsius. All right, greenhouse effect is at 12.5 Celsius, which means we're gonna have some water on our planet. We need to bring the water down. We need to bring organics down as well, and that way we can get some more water. And there we go. We have some frozen surfaces on Pluto. We just need the temperature to go up, which I'm pretty confident it will. The atmospheric mass, because yeah, we need to have 1 atmosphere on Pluto. Okay, And hopefully that will hopefully bring us to Earth likelihood. I'm just gonna speed it up. I'm gonna put it to about 12 Celsius, and hopefully this will make the water melt. Is it still gonna be increasing at 12.2? I really hope this greenhouse effect isn't gonna keep making it go up. So I can always bring down the atmosphere. Let's bring down the atmosphere then. Okay, so show atmospheric mass. We're gonna bring it down to, actually, why is the surface pressure at kilopascals again? Life likelihood is now at 0.281. Okay, that's looking really, really good. Now, how do we increase that? I actually just loaded up a new simulation because I got really tired of that lag. So I'm quickly just going through here. Earth similarity is at 0.862, so very similar to Earth. So now, Earth. Water, let's increase the water so I can get it to have oceans. I don't know how much that's gonna take. There we go. Okay. It's just carpet bombed all over Pluto. All right, so now that I have water here, Earth likelihood is still at 0.216. So how do we get the other 80%? What is the other 80%? We have the temperature. It's a comfortable temperature. We have atmosphere that is at, maybe it's the atmosphere. Maybe we just need more atmosphere, but how do we get rid of the greenhouse effect with all of the atmosphere? Increase the albedo. That's what we might, the albedo that I learned, and I think it was from you guys in the comments, unless I read it somewhere else. The albedo is actually how much light reflects off of the planet. So if you take, for example, on Earth, our ice caps, that reflects sunlight away from the Earth, and it does not get absorbed, which means it makes the planet less hot, which is actually what is very important about our ice caps. If we get rid of our ice caps, our planet is going to absorb in more heat, which it also explains why if you wear a black shirt in the sunlight, you're gonna get more warm as opposed to a white shirt because it's reflecting white light away. Okay, come on, don't increase anymore. Don't increase much more. Don't increase much more. You're being a colder planet. You should stay as a colder planet. It's not increasing that much more. It's slowing down. We might have found a comfortable temperature. It is slowing down 9 Celsius. If we can get to it, oh, we might have done it. This game needs to have a way to change the atmospheric makeups, because there's no way I'm only able to change the atmospheric mass, but there's no way, like, I could put in oxygen, I could put in the CO2. I can only just add mass. I mean, this could be poisonous gas that's 1 atmosphere. Now the Earth similarity is at 0.973, and the life likelihood is at still at 1.166. Maybe I need to change the axis of rotation, because maybe that is just getting to be a little bit off. Let's see. Let me go back to Earth. Okay, change the axis of rotation of Earth, because that is a thing. If your axis of rotation is really weird, then you can end up having really extreme summers and really extreme winters, and that could really affect the likelihood of life. So the radius, no, motion is probably what it's going to be. The axis is at 23.4 here. Pluto's is at 116. So if I make it 23.4, okay, we keep it there. How is our likelihood of life? Made it a little bit more Earth-like, but the likelihood of life is still shit. Oh, and the surface pressure is now 3 atmospheres. Why did I do that? No, give me 1 atmosphere. Oh, now we have made ourselves more likely to have life. We're almost at 0.3 now. Temperature is at 12 Celsius. Okay, the albedo I need to bring down. Okay, I think we have hit a point now where I don't know if I am going to get any better, but you guys can let me know if I can get any better with Pluto here, which has a almost 80% chance of having life. So there's probably some kind of life here. So much water everywhere. I'm actually gonna do one last thing, and I am going to add just a little bit more water, just so I can have bigger oceans. It's a huge Huge water planet. Now, oh my god. Let's see here. Even more likelihood of having life. Okay, no. Oh, now that's too much water. Or not enough water. Okay, the more water I add, what is the most ideal amount of water for me to have life? This gets me well into the 80% here by having this much water. 8.4, 8.7, 8.69. Okay, no. Okay, now let's add some organics and see if we can get this up a little bit. 8.7, an 80% chance of having life with all of this. 88% chance there. Okay, come on. Can we get a 90% chance? 87% chance. We're almost at 88% chance. We're at 98, almost 97%, 99% like Earth. Pluto is an island planet. It's just basically a water world. Lots, God, the way of traveling through here, you have to like squiggle around here. Just imagine the civilizations. Not a whole lot of landmass, which I'm assuming there would probably be a lot of wars. Oh my God. 88%. The surface temperature is at 11 degrees Celsius. Let's see here. This is basically the stats of the planet we got here. The mass is 1.03 Earths here. The surface gravity is at 10.2 meters per second squared. So you're a little bit heavier on this planet. Escape velocity, blah, 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 blah. It's at 1.25 AU, which is basically 1 AU is the distance from the Earth to the Sun. So it is 25% further. Yeah, surface temperature is at 11 point blah, blah, blah Celsius. It's got, it's a little bit thinner of an atmosphere, but not too much. The motion is the coolest part. Yes, I mean, you got the surface, the temperature and the gravity is very similar. But what do we have here? We have 24.6 hours in one day. It was actually 25 earlier. I don't know why it changed. Let's see, the axis is at 49.6 degrees Celsius. Or no, the axis of the way the planet spins is at 49 degrees, so it's actually going to be very, very different. I think Earth's axis of rotation is at 23 degrees, but this is at like 49 degrees, so the differences in seasons are going to be great. Like, you know how in the equator, below the equator, everything is flipped, or above the equator, below and above the equator, our seasons are flipped. So in summer, in the northern hemisphere, is winter in the southern hemisphere. Well, it's gonna be much more extreme, I guess. That would be what it would take to make Pluto a planet inside, or a habitable planet in the Goldilocks zone. A lot of changes to the planet. I can't believe we just made Pluto habitable. I really wish it would change to actually... I want planets to be able to have a climate tab, because I want clouds on the planet. I want to start seeing some trees growing, but you can't quite get that yet. But yeah, I made Pluto habitable with a, with an 88% chance of life. I am sure there is a way of getting that to work, and that's the magnetic field as well. Hold on, no, wait, no, we're not done yet. We are not done yet. We are going to, I need to turn this thing off here. Should the magnetosphere off? We don't have a moon. What if we have an 88% chance of life? The moon is very important to us, so let's add moons. Our moon, let's get it to about right here. Now, what on our planet? What's the? Does that change anything? It didn't change anything. Oh, come on! That would have been a cool theory. If that added like a 10% likelihood of life. Come on. I thought that would have been it. Okay, well, you know what? This planet hasn't really experienced any disasters. Let's just assume we got the dinosaurs here, or the first era of life. Well, guess what? Let's get a nice comet, a random asteroid, or actually, let's get a really big thing going here. Halley's Comet is gonna hit us. Come on, boom! Does that destroy the planet? No. We need to have like a colossal impact here. Let's. Okay. Slow it down. All right. World-ending body hits the planet. Boom! There we go. Giant impact causing chaos on the planet. Oh, and then all these things are gonna rain back and hit the planet some more. It's still likely that something survived. We need to get this to a point where there's absolutely no way anything has survived the comet. Okay, let's make a Halley's Comet. Hit the planet some more. Gonna bring down that life likelihood. We're gonna make all the life extinct on this planet. Yes! There we go. Okay, now there's still a 60% chance that all life on this planet has survived. Well, you know what? Let's make Pluto collide with itself. God, the amount of changes that we had to make on this planet. There's still a 24% likelihood that something has survived on this planet. They probably survived on this side, so let's kill these guys. Okay, and kaboom. Oh, there's still a... Oh, yeah. Now we've made everything extinct. But it's still a little bit... There's still something in common with Earth right here, so... Alright. Alright, now let's just give it a ring. Ordered... Yeah. Can I add the ring, please? Add a ring. There we go. Now we got an ordered sphere with the planet. Now let's just make Pluto pass right through it. Actually, everything is being disturbed right here. Yep, it's all strange. And oh, here it goes. The gravitational influence is causing the rings to dance, and kaboom. All right, we've successfully created life and we have destroyed it. Now, I think I am done with the simulation, so I will see you guys later.